Hi guys, welcome back to another video by TechMe Academy. I just want to go over some series impedance questions. So we're going to calculate the series impedance of a circuit. Then we're also going to remove the capacitor and then determine what capacitor size we need to achieve resonance. And then we're going to remove the inductor and then check what size inductor we need to achieve resonance with the resonance formula for a series RLC circuit. So we're going to cover series RLC and resonance today.
Got a series RLC circuit, which means that your resistor, your inductor, and your capacitor are in series with the AC sinusoidal input voltage. We're gonna tag it as 100 volts AC RMS, 100 hertz frequency, a 20 ohm resistor, a 20 millihenry inductor, and a 200 microfarad capacitor will be in our circuit. So now we want to know Z, which is square root R squared plus XL minus XC squared. We have our inductive reactance and our capacitive reactance formula, which is XL is equal to 2 pi FL, which is equal to 2 pi 100 times 20 times 10 to the power minus 3. Why? Because it's millihenry and the standard notation is Henry. All right, which is then equal to, all right, it's 20 millihenry. All right, this gives us 4 pi, which is simplified to 12,566, okay, to 3 decimal places ohms. All right, that's our XL value. And our XC value then will be 1 over 2 pi FC. It's exactly the same as the other value, just 1 over, with a C replacing the L. All right, which is 2 pi 100 times C, which is 200 microfarad, which is 200 times 10 to the power minus 6, because the standard notation is farad. All right, which is equal to 7,9577 ohms. Then calculate our Z, which our formula for Z is over there, right, which is going to be 20 squared plus the larger of the two, which is still XL, 12,566 minus 7,9577 squared. Okay, which is then equal to 20,524 ohms is the total impedance, right? All right, and then another question I get a lot is, does it matter which side you put XL and XC? No, not really, as long as your absolute value is positive and added to the total resistance, because total resistance is your lowest impedance, right? If that makes any sense. Trick question, right? Now I go and ask you to remove this capacitor and make the circuit resonant with only the inductor in it. All right, so what we're going to do is we are gonna equate XL has to be equal to XC, and seeing that they deduct from each other in the total impedance formula, that would be their lowest value, right? And that's resonance as well. So all right, so let's go and take our XL, which we got as 12,566, has to then equal XC, which is 1 over 2 pi FC, right? And that's 12,566, which is equal then to 1,26655 times 10 to the power minus 4 farads, right? Okay, cool. Now I got the farad value that I tell you nullifies the inductor. So now I got the farad value that I said nullifies the inductor, but let's go and truly see if it nullifies the inductor. So when I have the capacitance, I can put it into the formula and then get its capacitive reactance, and then it just has to equal. How big does my cap have to be for resonance? Let's go and test it quickly. Okay, so our capacitive reactance after the calculation is then equal to 12,566, which is then equal to XL, so they will cancel via the impedance formula here, and resonance will be achieved. Vice versa is exactly the same for the inductor. So with the inductor, if you go and take out this inductor, let's go do that calculation quickly. Let's go and take out this inductor and we only leave the capacitor. So now I tell you, go and calculate the inductor value that nullifies the capacitor so that there's resonance in this circuit now. Our formula for XL is 2 pi FL, and then we equate that to our capacitive reactance, which is 7,9577. And then we leave the L on this side and we say 7,9577 divided by 2 pi 100, which is then equal to 0,01266 Henry, 65 Henry. If we test it in the formula for inductive reactance to make sure it cancels out our inductor, which is only 7.9, let's make it 8 ohms. Okay, so we've taken out our inductor and then basically said we have to size the inductor for resonance, and we've done the same with the capacitance. So basically RLC circuits have been checked off for the basic calculations of these passive components. Thank you, stay tuned.